Alright, let's talk about solving quadratic equations. There are several different ways that we can solve a quadratic. The first three ways are ways that we can do it algebraically. Now, the first one is factoring. We know we can't always factor a quadratic. Okay, some are just plain and simply not factorable. If that's the case, then you want to either use the quadratic formula or the complete the square technique. If you are allowed to use a calculator, the easiest way to solve is to do it graphically. Okay? And if we're given information where we know our solutions are integers, then it's not a bad idea to use a table. Okay? But usually when we set up a table, we go by integer values. So if you have information, if we know our solutions are supposed to be integers, then it would make sense. But beware, if you have a decimal out there as one of your answers, it's not going to show up in a table. Okay? So we're going to do one example here, and we're going to use all 5 of these methods on that one example. Okay? Alright, so here is our quadratic. X squared minus 2x equals 8. First thing you generally want to do, regardless of how you're solving, is to bring everything over to one side and make it equal to 0. Okay? So our first way of solving this is going to be to factor. Okay? So this can be factored. Okay, this would be x plus 2 and then x minus 4. Those would be our factors that add to negative 2 and multiply to negative 8. From there we set each factor equal to 0. We get negative 2 and we get positive 4. So those are our solutions when we factor. Okay? Okay, so suppose maybe you didn't know how to factor that, or suppose we have something that's not factorable. We could always use our quadratic formula. So we have x equals negative b. Now I'm going back up here to this ax squared plus bx plus c form. So we're going to fill in our pieces. So x equals negative b, so that would be a positive 2 plus or minus the square root of b squared. So negative 2 squared is going to give me 4 minus 4 times the a, which is 1, times the c, which is negative 8, all over 2 times a, so that's 2 times 1, which is just 2. So let's clean this up. We have 4 plus a 32, which is 36 underneath the radical. So we're going to have 2 plus or minus, and then that radical 36 just becomes a 6. Now from there, we have 2 plus 6 divided by 2, that's one solution. And we have 2 minus 6 divided by 2. Well, that is going to give me, for my first one here, 8 divided by 2, which is 4 for that x value. And then here, 2 take away 6 divided by 2, that's negative 4 divided by 2, so that is my negative 2. So notice, of course, we're getting the same answers, just using a different technique. Okay, so let's do complete the square next. Okay, so we're going to go back to our original equation here. So if I do the complete the square, I'm going to take this negative 2, I'm going to divide it by 2, and then I'm going to square that. Well, that's going to give me a 1. Okay, I'm going to bring down that minus 8. We're going to say to ourselves, well, how do we change this problem? Well, we added 1, so to balance it off, I need to subtract 1. Okay, so from there, this trinomial becomes x minus 1 quantity squared minus 9 equals 0. We're looking to solve for x, so I'm going to add over my 9. So x minus 1 quantity squared equals 9. I can now square root each side, but don't forget you're going to need a plus or minus. Okay, so the square root will kill the square, so we're going to have x minus 1 equals, but I need a plus or minus in front of this. Radical 9, of course, is 3. So when I then add over 1, x equals 1 plus or minus 3, which of course is going to give me 1 plus 3, which is 4, and then we're going to have 1 minus 3, which is negative 2, so we get the same solutions. So when would you have to use complete the square? Well, usually it's either complete the square technique or quadratic formula. Alright, you use either one of these if it's not factorable. Okay, so some people prefer quadratic formula since it's given to them in their formula packet. However, with complete the square, there's certainly some advantages of doing that over quadratic formula. Okay. Okay, our next technique is to look at how to solve this graphically. So this is where you would be allowed to use a calculator, and it might just say solve. It's not really ever going to tell you guys in a question, hey, solve this graphically. Instead, you're just going to know you're allowed to use a calculator, and the question is just going to say solve. Okay, so especially for your more complicated equations, you want to make sure you remember this technique of solving by using a graph. So we want to know, where is this function x squared minus 2x minus 8 equal to 0? Well, you can see that it's equal to 0 there and there. So you want to use the 0 button on your calculator under second calc to get these solutions of x equals negative 2 and x equals 4. Okay, so make sure you know how to use that 0 button. All right, you have to do it 2 times to find the zeros of that function. Okay, and our last technique here is to solve using a table. And again, it makes sense to use this if we somehow know that our answers, our solutions, are supposed to be integers. So we are simply looking for where the equation is equal to 0. So in y, I have my x squared minus 2x minus 8, and these are all the values we get for the x values that are shown. Well, notice that when x is negative 2 and when x is positive 4, the y value is 0. That's what we're looking for. So from this we can gather that our solutions are negative 2 and positive 4, which we put in the solution set. Okay. The vertex, by the way, is right here at 1 comma negative 9. We can get that information from when we did the complete the square technique in a previous step. And you could also notice right here in your table of values, you can see this symmetry pattern around your vertex, right? So right here at 1, negative 9, you can see the vertex in your table quite nicely, okay? So look for that pattern. But the bottom line is you want to be cautious about using a table of values to solve. Again, we're only going to use it if we know our solutions are integers.